Hello and welcome to this video on battery thermal simulation with reduced order models using Ansys Digital Twin. We have here a battery module with 12 cells, a cold plate with liquid coolant going in and out. The first step would be to run a cold flow simulation with just the flow turned on to establish the flow of the liquid coolant, and that would be done with the heat release of the cells set to 0 and the tab current is also set to 0. After that's done, we'll turn the energy equation back on using solution equations, so the energy is on. And then we'll go to our battery model. You can see here that we're using CH decoupling. We have enabled Joule heat and passive zones. Our cells are conductive, our tabs and conductors are passive. We have a negative and a positive terminal, and the heat source per battery cell is set to 0, as well as the tab electric current. Activating the ROMs is done within the battery ROM toolkit under the advanced options. So turn that on. This is going to be an LTI, which stands for linear time invariant. Set the volume heat for the cells. So using the filter, and grab the cells like that. The next step is to set the value. So this would be 120 watts for all the cells combined. And we'll add that as a group. Do OK. Use a tab current of 200 amps. And then the cell zone average, we'll pick on the cells again. Pick them, and I'll add them individually this time. We'll increase the initial time step size to half a second, and we'll use a max time 36,000. And then the next step will be to apply, and then to click on Run Training. In Ansys Twin Builder, we access the ROMs for LTI by going to the Twin Builder menu, down to the Toolkit, Thermal Model Identification. And we have for single input, multiple output, we'll have 2 inputs and 12 outputs. Leave the name Thermal ROM, keep the methods. Instead of the file format default, we'll switch to Fluent. And then for the file location, we'll go look at the file menu here, file folder. So there's the LTI that was generated. That generated these files. And so we're going to pick on this LTI folder. Click on Generate. Press on the key. Said OK. We'll close that. So now in the project components, we'll drag and drop this component and escape. And then we'll add 2 constant inputs. One here, one there. Escape. So for current, we need to have a squared term. So add the squared component, then use connections to connect these. This one up to the Joule heat, and this to the cell load. We'll set the constant here to 120. And set the current constant to 200. In terms of generating outputs, we would generate a standard report, rectangular plot. Fortunately, our outputs aren't here, so we have to go up to Twin Builder, to Output Dialog, and add these by checking their boxes. Check all 12 of them. they're all there. We can click on close. And we can try again with the results, standard plot, rectangular plot. Now they're all here, so we can highlight them, create the new report. We'll close that, and we'll set up transient analysis, do an edit on that. We'll change the final time to 36,000 seconds. A minimum time step, 0.1 seconds, and a maximum of 5 seconds. And then we'll run the analysis. And as you can see, that only took a couple of seconds to run. For the multiple input, multiple output ROM, there's a very similar process. Run the cold flow and then turn on the energy equation and go into the battery model. And then in the advanced options, so battery ROM toolkit, at this time for volume heat, pick on the cells, select all. Here we'll just put an heat input value per cell. So only 10 this time. And this time we'll add individually instead of as a group. Do OK. And turn on the tab current. That for cell zone will be the same as before. All add individually and OK. And then do an apply and run training. When it comes to the twin builder, I already have the model set up. I'll walk through some of the steps again. So toolkit, thermal model identification. This time the number of inputs will be 13. So 13 inputs for the heat load and then 1 for the joule heat, and then the number of outputs would be 12. And again, we'll switch on Fluent, and then for the file location, it would be the LTI folder that was generated in the training. And this time the training, it took about 3 hours to do. With the schematic, again, we drag the thermal ROM into the window, dragged into the 2 constants, and also dragged in the square function. So this time the constant value is going to be 10 for the heat load, and we'll still use the 200 for the current. And it's the connectors. The connector for the heat load went through all the input nodes for the input volume heat. The next step would be to set up the outputs. And so I set up an XY plot again, and then also set up the inputs for the transient run. And then the last step is to do the run. It appears to have finished. So we'll plot the results so you can see that only took a couple of seconds to run. That's it for this recording. Thank you for watching. Bye-bye.